Hello everyone, welcome to my talk, SETSTATMAP, Extending Parallel Sets for Visualizing Mixed Data. I am Devajyoti Mandal, and this is a joint work with Shisham Wang, Sarah Shatri, Chanchal K. Roy, James S. Fabigliati, and Kevin A. Schneider. We are from University of Saskatchewan. As you can see, in my talk, I will be talking about visualizing mixed data, and I will also be using parallel sets. To discuss this, we first need to have a brief overview of parallel coordinates. Parallel coordinates are typically used to visualize high-dimensional numerical data. As an example, here you have a table of 7 data points, and each data point has 9 dimensions. In a parallel coordinate visualization of this data point, we have a vertical axis for each dimension, and for each data point, we have a line for its corresponding values cutting through these dimensions, as you can see here. Parallel coordinates visualizations are very powerful because it is compact. You can add dimensions by just adding vertical lines, as well as they can reveal patterns in the data. For example, if you focus on the dimension 1 and 2, you can see a few lines which are nearly parallel, and that pattern corresponds to a positive potential relation between dimension 1 and dimension 2. Similarly, if you look at the dimension 5 and 6, this is a pattern that will relate to a negative relationship between dimension 5 and 6. However, such a parallel coordinate visualization without any modification does not handle categorical data very well. For example, this is the Titanic survival or perish dataset, where you can see that there are first-class male passengers which are adult, and 118 of them did not survive. In total, you have 32 different combinations. Now here you can see all these combinations, 32 combinations in this table. And if you look at the first class passengers, it is very hard to differentiate between how many male versus how many female. Similarly, for the second class, the opacity does not allow us to differentiate between the number of male or female. To tackle this problem, Bendix et al. Proposed parallel sets. Now this is the parallel set visualization of the same data. You can see that the frequency of each set is better visualized. For example, if you look at the first class, I can now see that there are more male passengers than female passengers, and the same holds in the second class. The parallel coordinates has been extensively used in the literature to analyze complex data. The underlying data of these different types of visualization may contain some temporal information, some spatial information such as lat, lon, some numerical parameters, or some categorical parameters. Now let's see some challenges in analyzing this type of data. Typically, there are many variables, and the scientist wants to examine the spatio-temporal distribution of all these variables. Now, they can be a side-by-side contour plot over different time steps, but this becomes very challenging to analyze or even compare pairwise relationship between variables. Sometimes they also want to compare two locations for a single variable or the distribution between pair of variables over these two locations. Now, if you think about the number of combinations they need to analyze, it can become very large very quickly. Since parallel sets can visualize many combinations of sets, this motivated us to extend parallel set to propose SETSTATMAP. The SETSTATMAP that we propose here contains a parallel set view, a statistics column view, a map view, and some controls. Now, in this case, the first axis of the parallel set is temperature, the next is precipitation, the next is solar radiation, and here you have months. The left side, you can see all these categories. We created these categories for the numerical dimension by computing quartiles. Let's look at the parallel set view closely. If we highlight the max range of the temperature, which is above the 75th percentile, we can see that this is spanned over June to September. While we have completely red in July and August, we have some combination of yellow and red in June and some combination of yellow and red in September. And the rows of the stat column are color-coded based on that. So if you look at this statistics column, which is precipitation, we can see in the month of June, the precipitation has a very high variability. Furthermore, we can also look at the trend that the precipitation, the median precipitation is decreasing for the month of June, July, and August, where if you look at the temperature on the background, the temperature is increasing over these 3 months. The SETSTATMAP allows you to select each of these month category. For example, here you can see the two views obtained by selecting the month September and the month August. As you can see, from August to September, the temperature decreases, so the red regions also decrease. Note that the color comes from the first axis, which is the temperature axis, and that allows us to interpret the distribution that we see on the map. The same way, we can augment the precipitation axis with some other visual cue. For example, here we show what happens when we map the precipitation to texture. Now, if you see small dots, that means the precipitation is low, and if you see the bigger dots, then the precipitation is high. Here, the small precipitation values are mapped with small dots, and the higher precipitation values are mapped to dots of bigger radius. Although this visualization may appear cluttered initially, it can be quite useful when we interact with them. For example, here we hover on the high value of precipitation, and all the ribbons that pass through this category are highlighted. We can see most of the places in June have high precipitation, but not all the places in July have high precipitation. Now, these will be clear when we see it on the map. In this picture, we have September visualized on the top and August visualized on the bottom. Now, we have discussed the temperature already. Now let's focus on the precipitation, which is the second axis. So we have to think about the dotted circles. By looking at the map, we can see that some part of Winnipeg has high precipitation here, and this part of the Winnipeg has high precipitation, whereas some part of Saskatchewan have high precipitation in September, but most of the Saskatchewan has low precipitation in August. In fact, the interaction is not limited on the month axis only. You can actually select any category that you can see on the parallel set view. For example, here we selected the lower quartile of the temperature, which is very cold, -1 to -4 degrees centigrade, and these are the colder months, November, December, January, February, and March. As you can see on the map, this part of the distribution is dark blue, indicating that most of the days in these months, we have cold temperature here over the Winnipeg area. And as you go to the west towards Calgary, you have higher temperature on this month. Now let's take a look at another axis selection or category selection, which is the lower quartile of precipitation. As we can look at the map, you can see that the whole region, we have small dots because the selected axis is low precipitation. So the only meaningful information here should come from the color, which is the temperature axis. The red region here indicates that with low precipitation, we can see high temperature in the Prairie Saskatchewan region, whereas with low precipitation, we can find low temperature in Lake Winnipeg or Winnipeg region. This provides us with a very convenient way to select a dataset based on one variable's range and look at the distribution of another variable over the range that we have selected. Sometimes this is interesting because it readily shows us the gap in the data. For example, here we selected the wind category where it is a very low wind, and we can see that in the Lake Winnipeg area, we do not have wind in this range. Note that the color is coming from max temperature and the dots are coming from precipitation. So we can say that the high temperature and high precipitation occurs over the Edmonton area together with the low wind in these June, July, and August months. So we can say that there exist days where we have high precipitation and temperature in June, July, and August month that coexist with low wind. In the bottom figure, I have selected high wind values, and we can readily see colder days over Saskatchewan and Edmonton. And these cold temperatures coexist with this high wind. That actually is consistent with so many extreme cold warnings in these colder months in this area. These are the typical interaction that SETSTATMAP supports. After loading the data, you can select regions and you can see the distribution by clicking on the month axis. You can also select any other axis in the parallel sets view, and you can sort the axis to examine the trend, and then you can also, of course, choose the color map based on the variable axis that you are using as the first axis. And then you can reorder the axis as you want, like the parallel sets typically support. And you can also change the opacity and colors. Now let's take a look at some of the features of SETSTATMAP that we have to be careful about when we are designing such visualization. As you can see here, we have used arbitrary textures to augment this parallel sets view. And if you use this type of arbitrary texture, sometimes you may face cutoff issues. For example, here you cannot say whether it is cutoff circle or cutoff waves. And sometimes the cutoff cross even may look like a cutoff wave. Other than that, you may have cluttered visualization in the parallel sets view, as you can see over here. That is why it is advisable to use simpler textures. But even with simpler textures, we need to be careful. On the left, you can see that higher precipitation is mapped to larger radii, and on the right, higher precipitation is mapped to higher opacity. Now, although here you can see the contour boundary or the high precipitation region quite well, it is very hard to distinguish the differences between opacities on the right picture. Another feature is the choice of axis. Sometimes we can reduce the number of ribbons that have been created by choosing uniform value split rather than using quartiles. So as you can see in the second picture, we used uniform bin of values, and that's why the axes are of different width, and you have much less number of ribbons than the first picture. If you are not selecting the axis carefully, sometimes you can choose something that may not be that meaningful. For example, here we have elevation, and the elevation doesn't change over various months. So if you look at the stat column, the whole elevation axis has the same bar plot as well as the background is the same. The only information you get is the west side has had elevation than the east side. Now let's take a look at the scalability of SETSTATMAPs. As we have seen earlier, instead of choosing quantile values, if we use uniform split, then the number of ribbons are much smaller, and that we can see also in the plot. So if you look at the first bar, so this is with quartile and this is with uniform split, and you can see that the number of crossings or polygon overlaps are much smaller in uniform. That is potentially because which is consistent with the number of polygons that have been rendered. The next thing that we examined is how much does it scale if I increase the number of axes. Now, as we saw from the experiment, up to 4 axes, that means 4 plus month, that is 5 axes, you can interact with the SETSTATMAP quite well, and it is and the rendering time is quite fast. But if you go beyond 5 or more variables, then the interaction becomes quite slow. We did interact with the domain experts to evaluate our technique. Now, after we designed our initial SETSTATMAP visualization, as you can see here, we interacted with domain experts with weekly on-hour meetings for over 3 months. Initially, we did not have proper units for these plots, and also the textures that we used were not intuitive for the domain experts to use. So they suggested to use simpler textures, color maps, and it took quite a lot of sessions for them to get used to these new types of visualization and to have confidence in how to interpret this visualization. Overall, they were very satisfied with the SETSTATMAP, and actually they liked the potential of SETSTATMAP to show multiple variables simultaneously over the map. And they suggested that we can focus on the long-term indices. Right now, the dataset we used for the experiments show monthly trend, but for the drought prediction or climate change, they need to visualize the standardized precipitation index and soil moisture deficit index over the longer period, over many years. They also suggested that one can integrate SETSTATMAP with the existing hydrological models, because sometimes the model output needs to be validated, and that's when they need to look at multifaceted information, and the SETSTATMAP can be useful by making all this information accessible in a very short period of time. Although in our current paper, we mainly focused on meteorological dataset, we also examined what happens if we use it for other datasets. For example, we used a vacation rental dataset from Airbnb, and we also found this to be useful in the case studies with graduate students. Now, in summary, we proposed SETSTATMAP, which leverages the idea of multiple coordinated views to visualize mixed data. The idea is to harmoniously blend 3 views: parallel set view, the statistics columns, and map view, and to present them in a linear fashion so that it becomes coherent and intuitive to explore. We demonstrated the functionality of SETSTATMAP using real-life datasets, and we believe our approach to visualizing mixed data, will inspire future work in visualization and interface design to explore heterogeneous data. And that concludes my presentation. Thank you all for listening.